In this video, we are going to discuss about current source inverter. A current source inverter is a device which converts DC input current into AC output current. The input behaves as current source and the output current is maintained constant irrespective of load on the inverter, and the output voltage is forced to change. Current source inverter is a dual of voltage source inverter VSI. The line-to-line voltage of voltage source inverter is similar in shape to the line current of current source inverter. The advantages of current source inverters are, as the input DC current is controlled and limited, misfiring of switching devices or a short circuit would not be a serious problem. And second one, the peak current of the power devices is limited inside the inverter. Third one, the commutation circuits for thyristors are very simple. And fourth one, it has the ability to handle reactive or regenerative load without freewheeling diodes. The drawbacks of CSI, that is control source inverters, are it requires a relatively large reactor to exhibit current source characteristics and an extra cover stage to control the current. The dynamic response is very slow. Due to the current transfer from one pair of switches to another, an output filter is required to suppress the output voltage spikes. Here we have a single phase current source inverter. This is the circuit diagram. We are going to get the IL, that is input current to the converter, constant IL. When T1 and T2 are fired, the current flows from the source Vs positive to T1, D1, load D2, T2 back to Vs minus. Then the current flow is from left to right. When T3 and T4 are turned on, then the current flows from Vs to T3, D3 through the load from right to left, D4, T4 back to source Vs. Then with respect to the load, when you observe, the current is reversed. That can be shown in a waveform like when T1, T2 are on. If I show the load current as positive, then when T3, T4 are turned on, then I can show the volt current in reverse direction. This is my output voltage I0. Here T1, T2, here T3 and T4. So the turning on process can be done by firing the thyristors when the anode voltage of the thyristor is more than the cathode voltage of a thyristor. In this circuit, if you observe, the turning off of the thyristor is not going to happen naturally, since the input voltage or the current is a constant one. It is not going to vary from positive to negative. Then the anode currents or anode voltages are going to stay constant and it is not going to be reversed. So the natural commutation process is not going to occur as the input is a constant. Then how to turn off the thyristors? That can be done by force. So forced commutation is used in current source inverter. The turning off process is nothing but a commutation process. So the commutation circuits for thyristors requires only a capacitor. By adding a capacitor here and here, let this be C1 and this be C2 to the circuit, and these two can take care of the commutation process of the thyristors. Let us assume that T1, T2 are conducting initially. Then the capacitor C1 is charged with the polarity positive and negative here with the voltage Vc, and the capacitor C2 is also going to charge to the voltage Vc with the polarities positive and negative. If I turn on or fire the thyristor T3 and T4, when I turn on T3, it's going to reverse bias the T1 and makes the T1 turn off. Similarly, I turned on T4, so which is going to make the T2 reverse biased and turn off. And this is done by impulse commutations. The current now flows from Vs to T3, T3 to C1, C1 to D1, D1 to load, load to D2, D2 to C2, C2 to T4. And the capacitors C1 and C2 are discharged and recharged at the constant rate determined by the load voltage, determined by the load current, that is Im, that equals to the input current IL. When C1, C2 are charged to the load voltage and their currents falls to zero, when Vc1 and Vc2 is equals to V0 and IC1, IC2 equals to 0, the load current will be transferred from the diodes D1, D2 to D3, D4, and D1, D2 will be turned off when the load current is completely reversed. The capacitor is now ready to turn off T3 and T4 if the thyristors T1 and T2 are fired in the next half cycle. The commutation time will depend on the magnitude of load current and the load voltage. The diodes D1, D2, D3, D4 is going to isolate the capacitors from the load voltage. The pulse width modulation or sinusoidal pulse width modulation or modified sinusoidal pulse width modulation or phase displacement techniques can be applied to vary the load current and to improve the quality of its waveforms. This is how a current source inverter with the thyristors and the commutation circuit is going to operate. If this video is useful, please like, share and subscribe.